Hello students. So today I am doing class for class 12 science. The topic is first order derivative. So same exercise 3a. So in the last online class also in derivative we were doing the same topic, that is first order derivative. Same exercise, that is exercise 3a. Each question carries 4 marks. So in the last online class on first order derivative, we did question number 17. We did question number 17. So today we'll do question number 18, number 1. The page number is 293. So this is the section. Each question carries 4 marks, right? So if y is equal to x to the power x dot 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 to infinity. So what is meant by it? X to the power x, again x to the power x, again power x, it goes up to infinity. That means which never ends. Okay? So then prove that, you have to prove that dy by dx is equal to y squared divided by x into 1 minus y log x. So let us prove it now. So let us write down the given here. So here given is y is equal to x to the power and dot dot dot, it goes up to infinity. Okay, that is x to the power x, again power x, which never ends here. Or now in this case y is equal to x to the power, again instead of, we have written 1x out here, to the power x is there. Again x to the power x, which never ends, it goes up to infinity. Instead of that value you can write y here, that is you can write x to the power y, that is y is equal to x to the power y. Okay, because the value of y is equal to x to the power x, which never ends up to infinity. So that's why y is equal to, you write one of the x here. So you write down this x, but for this power x to the power x, again power x, which goes up to infinity, which never ends, instead of that power you write y there. Okay? So now you can prove this result, but both the base and the powers are the variables here, so you cannot differentiate it directly. You have to take log on both the sides. You know that method, isn't it? So taking log on both the sides. Taking log on both the sides. So what do we get? Log y is equal to log x to the power y, or log y is equal to, you know properties of logarithm, y comes in the front, so it is y log x, right? So you have to differentiate both the sides with respect to x. So write down differentiating both the sides. We differentiate these functions, both the sides, with differentiating both the sides with respect to x. Or now what is the differentiation of log y with respect to x? First of all, it is 1 upon y into dy by dx. Is equal to, on the right hand side you can use UV rule. Y is kept as it is, log x differentiation with respect to x is 1 upon x. Then plus log x is kept as it is. Then this log x is kept as it is. Then differentiate y with respect to x. What is the differentiation of y with respect to x? It is dy by dx, right? So it is dy by dx. So is that clear to all of you? Now you have to solve for dy by dx and prove that given result. Okay. Now keep the terms containing dy by dx on the left hand side. So it is 1 by y into dy by dx minus log x into dy by dx is equal to, it is y upon x. So now let us solve for dy by dx. What is common here? Or it is dy by dx within bracket 1 upon y minus log x is equal to, this is y upon x, right? Now let us simplify it. Or dy by dx. Now within second bracket, what's the LCM here? It is y, right? So 1 minus y log x, which is equal to, on the right hand side, it is y upon x. Now what is the value for dy by dx here now? Or dy by dx is equal to, now you can do cross multiplication here. Y into y, this is y square divided by, now this is cross multiply 1 minus y log x by x. That is x within bracket 1 minus y log x. So this is the answer. So which is proved. Is that understood now? We have got dy by dx equal y square divided by x into 1 minus y log x. Now we'll do the next problem now. So now we'll do the next question, that is 18 number 3. If y is equal to x plus 1 upon x plus 1 upon x plus dot 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 to infinity, prove that dy by dx is equal to y upon, in the denominator, 2y minus x. So what is given here? Y is equal to x plus 1 upon x plus 1 upon x plus dot 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 to infinity. You have to understand the meaning of this given, right? So y is equal to x plus 1 upon x plus 1 upon x plus dot 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 to infinity. It means that y is equal to x plus 1 upon x plus 1 upon x plus 1 upon x plus again 1 upon x plus again 1 upon x plus, it goes up to infinity, which never ends, right? So this is the given part. So therefore this given part is, so y is equal to, let us write down this x plus 1 upon, again this means, this denominator, it means x plus 1 upon x plus 1 upon x plus 1 upon x plus, it goes up to infinity. So instead of this denominator, again you can write down here y. Is that clear now? So y is equal to x plus 1 upon y. This is the simplified expression. Now you can simplify it and differentiate. Okay? So or y is equal to, now here was the LCM, it is y. So below x there is 1. So y is divided by 1 to get y, and y is multiplied by numerator, that is xy, plus this is 1. Now cross multiply, y into y square is equal to, this is xy plus 1. Is that clear? So now you can differentiate both the sides with respect to x to prove dy by dx is equal to y upon 2y minus x. Okay? So now differentiating both the sides, with respect to x. Okay? Now let us differentiate the left hand side. What is the differentiation of y square? First of all, it is in the form x square. What is the differentiation of x square with respect to x? It is 2x. But we are differentiating y square with respect to x. So first of all, you should write 2y. Again, y was assumed as x. You have to differentiate with respect to x. That is, what is the differentiation of y with respect to x? It is dy by dx, which is equal to, now on the right hand side, xy is there. You have to use the product rule for its differentiation. So x into, what is the differentiation of y? Dy by dx, that is with respect to x, plus y into, what is the differentiation of x with respect to x? What is the differentiation of x with respect to x? That is 1. Is that clear? So now you have to keep the terms containing dy by dx on the left hand side. That is 2y dy by dx minus x dy by dx, which is equal to y. Okay? Now we can take common. What is common out here? It is dy by dx So within bracket 2y minus x, which is equal to y. So what is the value for dy by dx now? So you can solve it for dy by dx. Dy by dx is equal to, it is y divided by 2y minus x. So that is your answer. That means we have proved it. Okay. So the value for dy by dx is equal to y upon 2y minus x is proved. So that is the answer. So now we'll do the next question. Okay. Now we'll do the next question, that is question number 19. So that the derivative of the first function, that is root over 1 plus x square minus root over 1 minus x square whole divided by root over 1 plus x square plus root over 1 minus x square with respect to, within square root 1 minus x to the power 4 is root over 1 minus x to the power 4 minus 1 whole divided by x to the power 6. Okay. So you have to find out the derivative of this first function with respect to second function is this one. So let us assume the first function as y and the second function as z, so that you can find out derivative of y with respect to z. That means you have to find out dy by dz. Okay. So let us assume, and you should prove dy by dz is equal to root over 1 minus x to the power 4 minus 1 whole divided by x to the power 6. So let y is equal to root over 1 plus x square minus root over 1 minus x square whole divided by root over 1 plus x square plus root over 1 minus x square, right? And z is equal to what? And z is equal to the second function. What is the second function there? Root over 1 minus x to the power 4. So now, let us find out dy by dx first, and then dz by dx. This is just like your parametric equation. This y and z are the two variables, and they are expressed in terms of a third variable x. Here x is a parameter, and this equation is known as the parametric equation. Now first of all, you have to find out here dy by dx. Directly differentiate it. Differentiating both the sides with respect to x. So what do we get? Therefore dy by dx is equal to, use u by v rule. You know u by v rule, isn't it? That is, denominator is kept as it is, root over 1 plus x square plus root over 1 minus x square. Denominator is kept same. So now differentiate the numerator. Now differentiate the first function in the numerator. What is its differentiation? 1 upon 2 root over 1 plus x square into 2x. Right? Into what? 2x. Is that clear? Again, minus sign is there. Again, what is the differentiation of the square root? 1 upon 2 root over 1 minus x square into minus 2x. Again, differentiate the term which is assumed as x. Actually, it was taken as root over x. What is the differentiation of root over x? 1 upon minus 1, minus sign is there. And then what is the differentiation of root x? 1 by 2 root x. Again, differentiate the function which is assumed as x. That is, you have to differentiate 1 minus x square, which is equal to minus 2x. Right? Third bracket is closed. Then minus sign is there. Now you have to keep the denominator as it is. That is root over, how much is it? 1 plus x square minus root over 1 minus x square. This numerator is kept same. So now here, again you have to differentiate the denominator and write it here. Okay. So what is the differentiation of root over 1 plus x square? 1 upon 2 root over 1 plus x square into minus 2x. You know that. Root over, what is the differentiation? Root over 1 plus x square. Take it as root x. 1 by 2 root x. And we had assumed 1 plus x square x. Again differentiate it. that is 2x, right? Then plus 1 upon 2 root over 1 minus x square. Again differentiate root over 1 minus x square. What is the differentiation of root over 1 minus x square? That is 1 by 2 root over 1 minus x square into what? 2x. Again into minus 2x. Again differentiate the term which is assumed as x. In this case we had assumed 1 minus x square as x. So what is this differentiation? What is the differentiation of 1 minus x square? It is minus 2x into minus 2x. This whole divided by what? Root over 1 plus x square plus root over 1 minus x square whole square. Is that clear? So now here you can cancel. You can cancel these 2 gets cancels. Here also 2 gets cancels. Here also 2 here 2 gets cancels, right? So let us simplify it further. So let us simplify it further. Or dy by dx is equal to, in the numerator, root over 1 plus x square plus root over 1 minus x square. Now within top bracket, what is here? This is x upon root over 1 plus x square, right? Minus into minus plus, minus into minus plus, and then what do we write? X upon root over 1 minus x square, right? Then minus within bracket root over 1 plus x square minus root over 1 minus x square. It is kept as it is. Then within third bracket, what do we have? X upon root over 1 plus x square, then plus this is plus and minus, sorry, this one is minus minus x upon root over 1 minus x square. Third bracket is closed, whole divided by. So let us write down the denominator as it is, that is root over 1 plus x square plus root over 1 minus x square. This is whole square. So this is the expression. Okay. So now again you have to simplify it. Again let us simplify it. So what's the LCM here? Or dy by dx is equal to root over 1 plus x square plus root over 1 minus x square, right? So what's the LCM here now? It is root over 1 plus x square, root over 1 minus x square is the LCM. So numerator will be x root over 1 minus x square plus x root over, this is 1 plus x square, right? Next one minus within bracket root over 1 plus x square minus root over 1 minus x square. Within third bracket also, what's the LCM? So what's the LCM out here now? It is root over 1 plus x square root over 1 minus x square. So this is the LCM. Then x root over 1 minus x square minus x root over 1 plus x square. So this whole divided by, in the denominator you write root over 1 plus x square plus root over 1 minus x square whole square. Is that clear now? So now here x is taken common. So x comes in the front. Then root over 1 plus x square plus root over 1 minus x square and root over 1 plus x square. This root over 1 plus x square minus root over 1 plus x square plus root over 1 minus x square. These are same expression. You can multiply them. Okay. So here also minus you take minus x common here, because you should write root over 1 plus x square in the front and root over 1 minus x square in this. You can write root over 1 minus x square as the second term here, so that you can multiply these two factors, right? So let us simplify it. Or this is dy by dx is equal to, here x is common, right? Here x is common. So within bracket we have root over 1 plus x square plus root over 1 minus x square whole square, right? Because if x is taken common out here, this is root over 1 plus x square plus root over 1 minus x square. This is also root over 1 plus x square plus root over 1 minus x square. These are the same expression. So if you multiply them, you will get whole square, right? Then again, this will be the LCM. So let us write down here, divided by root over 1 plus x square, root over 1 minus x square, right? So now here we take minus x as common here, and we write root over 1 plus x square in the first term as the first term, and root over 1 minus x square we will write it as the second term. Okay, so minus with minus plus. So it is plus x because minus x is taken common here, minus with minus plus x. Now it is root over 1 plus x square minus root over 1 minus x square whole square. Is that clear? Because if you take minus x as common, you will have root over 1 plus x square as the first term and root over 1 minus x square as the second term. And these two expressions are multiplied to get whole square. Divided by root over 1 plus x square root over 1 minus x square. Okay, so whole divided by what? Whole divided by, this one is root over 1 plus x square plus root over 1 minus x square whole square. Is that clear to all of you? So now let us simplify it further now. Now or dy by dx is equal to, now what's the LCM in the numerator? That is root over 1 plus x square into root over 1 minus x square will be the LCM. And numerator will be these two terms. You can simplify it further. What is common here now? X upon, that is root over 1 plus x square root over 1 minus x square is taken common out here, right? X divided by root over 1 plus x square, root over 1 minus x square is taken common out here. So within third bracket, what do we have? We have here root over 1 plus x square plus root over 1 minus x square whole square plus, then it is root over 1 plus x square minus root over 1 minus x square whole square. Third bracket is closed. So this whole divided by, what will you write here now? You can simplify further, a plus b whole square. You know that what is a plus b whole square? A square. What is a square? Root over 1 plus x square whole square plus what is b whole square? Root over 1 minus x square whole square. That is your a square plus b square plus twice ab. What is plus twice ab? Plus twice root over 1 plus x square into root over 1 minus x square. Okay. So this is your a plus b whole square. A square plus b square plus twice ab. Okay. So next. So these are the denominators term, right? So or now it is dy by dx is equal to, now it is x divided by, you can multiply these two factors within square root. If there is root a into root b, this is root over ab. Similarly here also root over, this is a plus b into a minus b is 1 minus x to the power 4, right? And within third bracket, you can simplify it further. A plus b whole square, same formula, a square plus b square plus twice ab. So it is root over 1 plus x square whole square plus what is b whole square? Root over 1 minus x square whole square plus twice ab. 2 into what is a? Root over 1 plus x square into what is b? Root over 1 minus x square. That is your plus 2ab. Then again plus sign is there. Okay. Again what is it? A minus b whole square. What is the formula? A square plus b square minus twice ab. What is a whole square? Root over 1 plus x square whole square plus b square is 1 minus x square whole square. A square plus b square minus 2ab. What is minus 2ab? Minus 2 root over 1 plus x square into minus twice ab, that is minus 2 root over 1 plus x square into root over 1 minus x square. Okay. So third bracket is closed. whole divided by, what is square root of 1 plus x square whole square? Square root will be removed. This is only 1 plus x square. Plus again, what is square root of 1 minus x square whole square? Square root will be removed. It is 1 minus x square. Right? Then plus 2 root over, you can multiply this to 1 minus x to the power 4. Is that clear? So here you can cancel. This plus minus gets cancels, right? So let us simplify further now. Here you can cancel this x square gets cancels, right? So or this is dy by dx. So these are in the denominators, is equal to x upon root over 1 minus x to the power 4. Then within third bracket, what is root under 1 plus x square whole square? It is 1 plus x square plus, what is root under 1 minus x square whole square? It is 1 minus x square, right? And these two are cancels. Then plus, what is root over 1 plus x square whole square again? It is also 1 plus x square. Square will be removed. Then what is the last term? Plus 1 minus x square. Okay? Third bracket is closed. This whole thing divided by 1 plus 1 is 2 plus 2 root over 1 minus x to the power 4. Is that clear? Now we can simplify further. This x square minus x square minus x square will be cancelled. You can cancel them, right? So let us simplify it further. So let us simplify it, or dy by dx is equal to, now it is x, right? 1 plus 1 plus 1 plus 1, 4 into 4 whole divided by root over 1 minus x to the power 4 into, what is common here? 2 is taken common. Within bracket, what do we get? It is 1 plus root over 1 minus x to the power 4. Is that clear? So we can cancel 2 1s are 2, 2 2s are 4, right? So we are getting the simplified form out here. So or it is dy by dx is equal, numerator is twice x divided by root over 1 minus x to the power 4 within bracket 1 plus root over 1 minus x to the power 4. Is that clear? So suppose this is number 1. Suppose this is number 1. So now, what was the second part? Let z is equal to, what was there? Let z is equal to, let z is equal to root over 1 minus, it was root over 1 minus x to the power 4, right? Let z is equal to root under 1 minus x to the power 4 was there. We had assumed z is equal to root under 1 minus x to the power 4. So let us find out dz by dx here. So right now, differentiating both the sides with respect to x. So dz by dx is equal to, is just like your root over x, that is 1 minus x to the power 4. 1 minus x to the power 4 is assumed as x. So what is the differentiation of root over x? 1 by 2 root x. But here it is 2 root over 1 minus x to the power 4 into, again you have to differentiate the term which is assumed as x. That is 1 minus x to the power 4 was assumed as x. So what do we get? Minus 4x cube. Right? So 2 1s are 2, 2 2s are 4. So what do we get here now? So dy by dx is equal to, so it is minus 2x cube divided by root over 1 minus x to the power 4. So let us mark it, it is dz by dx. It is dz by dx. Let us mark it number 2. Now actually, first function was assumed as y and the second function was assumed as z. You have to differentiate y with respect to z. That means you have to find out dy by dz. That means dividing 1 by 2. So write down dividing 1 by 2, right? Let us divide 1 by 2. Okay, so left hand side should be divided here. Now let us write left hand side of number 1 in the numerator, that is dy by dx, divided by, in the denominator what we do write? Left hand side of number 2, that is dz by dx, that is dz by dx, which is equal to next. Now let us write down right hand side of number 1 in the numerator, that is 2x upon root over 1 minus x to the power 4, then within bracket 1 plus root over 1 minus x to the power 4, right? Whole divided by. Now let us write down right hand side of number 2 in the denominator, but that is on the right hand side, that is minus 2x cube divided by root over 1 minus x to the power 4. Is that clear now? So you can cancel here. So what can you cancel here? Root over 1 minus x to the power 4 can be cancelled. This 2 will be cancelled, and x 1 x, it goes x square times. So if you divide x cube by x, you will have x square in the denominator. So let us write down the remaining terms. What are the remaining terms here now? Now it is dy by dz. This dx will be cancelled. So it is 1 upon 1 plus root over 1 minus x to the power 4 into. So when this denominator goes up in the numerator, it becomes minus 1 upon x square. Is that clear? So this is the term. So now our dy by dz is equal to, minus sign is taken outside, 1 upon, this is x square within bracket 1 plus root over 1 minus x to the power 4. But what is to be proved here? But you have to prove that root over 1 minus x to the power 4 minus 1 whole divided by it is x to the power 6. But this is the required answer. You have to prove this. Okay? And now you can rationalize the denominator. Let us rationalize the denominator there. Okay? So let us rationalize it. So let us rationalize the denominator. Therefore, dy by dz is equal to minus. Let us rationalize the denominator. That means by which factor will you multiply both numerator and denominator? 1 minus. That is 1 minus root over 1 minus x to the power 4 divided by, in the denominator it is x squared. Now it is 1 plus root over 1 minus x to the power 4 into 1 minus root over 1 minus x to the power 4. So the denominator is rationalized, or dy by dz is equal to, now here multiply by minus sign, what do we get? Root over 1 minus x to the power 4 minus 1 whole divided by x square within second bracket. What is the formula that you can use here? This is a plus b into a minus b. So it is 1 whole square minus root over 1 minus x to the power 4 whole square. Second bracket is closed. Or dy by dz is equal to root over 1 minus x to the power 4 minus 1 divided by x square within bracket. What do we get? What is 1 whole square? 1. What is root over 1 minus x to the power 4 whole square? Its square root will be removed. You will get 1 minus x to the power 4. But because of this minus sign here, the sign changes. That is minus 1 minus into minus plus x to the power 4. Right? So, or what is dy by dz now? Numerator root over 1 minus x to the power 4 minus 1 whole divided by, this 1 will be cancelled. And what is x square into x to the power 4? That is x to the power 6. That is proved. So I think you have understood it. Okay. So we got the result, that is root over 1 minus x to the power 4 minus 1 divided by x to the power 6. Okay, so you can copy it. Let's do the next question now. So now we'll do the next question, that is each question carries 5 marks, page number 294, but this type of question you may get in 4 mark section. Okay, so there is another type of question now. Find the derivatives with respect to x, that is question number 3. Number 1 is x to the power x square plus a to the power x square. Let us assume it as y. So let y is equal to x to the power x square plus a to the power x square. So for the first term, both the base and the powers are the variables, that means you have to take log here. But this base a is a constant but power is a variable. In this case we don't need the we don't need log here. Okay, for here, since this base and the powers are the variables, you have to take log here. But for the second term, a is constant but only power is a variable, so we don't take log out here. Okay, but in this case you cannot write log on both the sides here, because if you write log on both the sides here, right hand side will not be simplified. Right hand, if you take log on both the sides, you will have log y is equal to, it will be log within bracket a to the power x square. Sorry, this is x to the power x square plus a to the power x square, which cannot be simplified, and this function cannot be simplified, right? So that's why you cannot take log on both the sides here. First of all, you take let y is equal to, first term is assumed as u plus second term is assumed as v. You should take u plus v form. Let us differentiate both the sides with respect to x. So u is x to the power x square and v is what? A to the power x square. But you cannot take log on both the sides, because log of u plus v cannot be simplified further. Okay, so let us differentiate it. So differentiating both the sides, with respect to x. So what do we get? This is dy by dx is equal to du by dx plus dv by dx. So let us mark it number 1. Is that clear? So now what we'll do here is, let us find out the value for du by dx and dv by dx first. Then you can put those values of du by dx and dv by dx in 1 to get the value for dy by dx. So let us find out first du by dx. That is, we had assumed x to the power x square as u. So let u is equal to x to the power x square. But in this case you cannot directly differentiate it, because both base and the powers are the variables. You have to take log on both the sides. So write down taking log on both the sides. Taking log on both the sides. So therefore what do we get? Log u is equal to log x to the power x square. Okay. So next, what do we get? Now this power becomes the coefficient because of that log, isn't it? So log u is equal to, here x square becomes the coefficient because of that log. This is the properties of logarithm. So x square comes in the front, and then you write log x. That is x square log x, right? So now you can differentiate both the sides with respect to x to get the value for du by dx. So differentiating both the sides, with respect to x. Okay, so what do we get? Therefore, what is d by dx of log u? First of all, you should take it as log x. What is the differentiation of log x? 1 by x. But here it is 1 upon u. Now this u was taken as x. Again you have to differentiate u with respect to x. That is du by dx is equal to, on the right hand side u rule, x square into what is log x, differentiation 1 upon x plus, now log x is kept as it is. Now differentiate x square. What is the differentiation of x square? 2x into log x is kept as it is, right? So here x and square gets cancelled. Now we can do cross multiplication. So du by dx is equal to u within bracket x plus 2x log x. Is that clear now? Now let us put the value for u, or du by dx is equal to, what was the value for u? U was x to the power x square. Let us write it here. X to the power x square into, again x is taken common out here. So x is common within bracket 1 plus 2 log x. Is that clear? So this is the value for du by dx. Right? So again you have to find out dv by dx. But what is v actually? V is equal to a to the power x square. Now let us write, let v is equal to a to the power x square. Okay? Now in this case, is it necessary to take log on both the sides? No, because your base is a constant and only power is a variable. That is, you can write down the formula for a to the power x here while differentiating. That is, what is d by dx of a to the power x? You know that differentiation of a to the power x is a to the power x log a base e. Okay? So let us write down differentiating both the sides. Differentiating both the sides with respect to x, right? So therefore it is dv by dx is equal to, now what is the differentiation of a to the power x square? You should take it as a to the power x. Which function is taken as x? X square. Okay? So what is the differentiation? A to the power x square into log a base e into, again which function was taken as x? X square. Then only it was differentiated. And now you have to differentiate the function which is assumed as x. That is, you have to differentiate x square with respect to x. That is into what? It is 2x. Is that clear? Next, or dv by dx. So, or dv by dx is equal to, let us write 2x first. 2x, then a to the power x square into log a base e. So we have found out both the values of du by dx as well as dv by dx. Now put those values of du by dx and dv by dx in equation 1 to get the value for dy by dx. So let us write, putting the values of du by dx and dv by dx in number 1. Okay? So let us write down number 1 now. So what is number 1 here? So dy by dx is equal to du by dx plus dv by dx. Okay? So therefore dy by dx is equal to, what is the value for du by dx? What was du by dx? This one. That is x to the power x square into x, and within bracket it is 1 plus 2 log x. So this is the value for du by dx. And what is dv by dx now? Plus, what is dv by dx? It is 2x into a to the power x square into, this is your log a base e. So this is the final answer. So I think you have understood it. So in this case, in this particular problem, you cannot take directly log on both the sides. First of all, you have to assume let y is equal to u plus v, or let y is equal to u minus v. Then differentiate it, dy by dx is equal to du by dx plus dv by dx. Then you have to get the individual values of du by dx and dv by dx, so that you can put the value of du by dx and dv by dx in that equation, that is dy by dx is equal to du by dx plus dv by dx, to get the value for dy by dx. Is that understood now? So now we'll do the next question. So now we will do the next question, that is 3 number 4. Here also find the derivatives with respect to x. It is given x to the power x plus sign is given. Sin x whole to the power x. Let us assume y is equal to x to the power x plus sin x whole to the power x. So for the first term also we did log here because both base and the powers are the variables. So you have to take log for the first term. Here also sin x whole to the power x. Base is the variable, power is also the variable. Here also you have to take log. But in this case you cannot take log on both the sides because there is plus sign here. If there is plus sign and minus sign, you can't take log on both the sides. But instead of plus sign and minus sign, if there is multiplication sign or division sign, you could have taken log on both the sides. But if there is plus or minus sign, you cannot take log on both the sides. So in this case, the method is different. So first of all, you should take let y is equal to u plus v. That is, x to the power x is taken as u and sin x whole to the power x is taken as v. Okay. So let us differentiate both the sides with respect to x now. So differentiating both the sides with respect to x. So what do we get? Dy by dx is equal to du by dx plus dv by dx. Let us mark it number 1. Now we have to get the values of both du by dx and dv by dx and put that value of du by dx and dv by dx in number 1 to get the value of dy by dx. Now let us first find out du by dx. Actually, what is u? X to the power x. So let u is equal to x to the power x. Okay. Now take log on both the sides. Taking log on both the sides. So what do we get? Log u is equal to log x to the power x. Or now what do we have? Log u, left hand side is kept as it is, log u is equal to log x to the power x. Now because of this log, this power x becomes the coefficient of log x, that is x log x. It is x log x. Now can we differentiate it? Yes, we can differentiate. So differentiating both the sides with respect to x, right? So therefore, what is the differentiation of log u with respect to x? It is 1 upon u into du by dx is equal to, now x into log x is there. You can use UV rule here. So x is kept as it is into, what is d by dx of log x? 1 upon x plus, again differentiate x, keeping log x as it is. Differentiation of x is 1. So 1 into log x. So here x gets cancels. Now let us cross multiply it. Or du by dx is equal to u within bracket 1 plus log x. Is that clear? So what is the value for u? Or du by dx is equal to, what is u out here? What is the value for u? It is x to the power x. So it is x to the power x within bracket, it is 1 plus log x. So we get the value for du by dx. Now what is to be determined now? You have to find out dv by dx. So what is b in this case? B was assumed as sin x whole to the power x. Let v is equal to sin x whole to the power x. Now here also you take log on both the sides. Taking log on both the sides. Taking log on both the sides. Okay. So therefore log v is equal to log, this is sin x whole to the power x. Now again, because of that log on the right hand side, power x becomes a coefficient. That is, log v is equal to x log of sin x. Is that clear? Now can differentiate it. differentiating both the sides with respect to x. Differentiating both the sides with respect to x. So what do we get now? So, or what is the differentiation of log b with respect to x? It is 1 by v into dv by dx, which is equal to, on the right hand side, you can use UV rule there. Now differentiate x, keeping log of sin x as it is. What is the differentiation of x? It is 1. So log of sin x remains same here now. We are using UV rule plus. Now x is kept as it is. X into. Now differentiate log of sin x. How do you differentiate it? You should take it as log x. What is the differentiation of log x? 1 upon x. But here it is 1 upon sin x into. Now again you have to differentiate the term which is assumed as x. In this case sin x was assumed as x. So what is this differentiation? Cos x. Sin x differentiation will be cos x. Or now dv by dx is equal to, now cross multiply by v here. V within second bracket, what do we get? Log of sin x plus x into, what is cos x by sin x? It is cot x. Second bracket is closed. Now let us put the value for v here, or dv by dx is equal to, what was the value for v? V was sin x whole to the power x. So it is sin x whole to the power x into, within second bracket, it is log of sin x, then plus x cot x. So this is your dv by dx. Is that clear? So now let us put those values of du by dx, that is du by dx and dv by dx, in equation 1, right? So putting the values of du by dx and dv by dx in 1. Number 1. So what is number 1 there? It was dy by dx is equal to du by dx plus dv by dx. So let us put the value out here. Okay. So therefore it is dy by dx is equal to, what is du by dx? What was du by dx? This is du by dx, isn't it? That is x to the power x within bracket 1 plus log x, right? Plus, now what is dv by dx? This one is dv by dx, that is sin x whole to the power x. Then within second bracket, what do we write? Within second bracket, what do we write? Within second bracket, log of sin x plus x cot x plus x cot x, second bracket is closed. So this is the final answer. So what is the value for dy by dx? It is x to the power x within bracket 1 plus log x plus sin x whole to the power x into, within second bracket, log of sin x plus x cot x. So this is the final answer. Is that understood now? So you can copy it. Now I will give you the homework now. So now these are your homework. That is 18 number 2 is if. So it is just like your 18 number 1, 18 number 3, we just did it, isn't it? So 18 number 2 is similar to 18 number 1 and 18 number 3. So 18 number 2 here is if y is equal to root over x whole to the power root over x whole to the power root over x whole to the power root over x, it goes up to infinity. That means which never ends here. Okay, then so that x dy by dx is equal to y square divided by 2 minus y log x. You have to prove it. Can do it. Okay. So question number 3 is find the derivatives with respect to x. So we did number 1 and number 4 here. So you can do number 2 and number 3 at home. So find the derivatives with respect to x. Number 2 is sine of log x plus x to the power cos x. You can assume here let y is equal to u plus v. So here the log is required, but in this case for sine of log x, no log is required out here. Okay. So you can assume that y is equal to u plus b here also. So you can use the same method as we have done in question number 1 and question number 4 of question number 3. And for similarly you can do this question number 3, sin x whole to the power cos x plus e to the power 3x. For this first function we need log, but for the second function we don't need log there. So you can assume here let y is equal to u plus b. So you can use the same method here also, which we have done in question number 1 and question number 4 of question number 3. So these are your homework. Okay, so this much is for today. So in the next class we will do more problems in this first order derivative. Is that clear? So you can copy it.